So number 2, the employees in an office were asked the following question: how generous do you feel is the amount of days allowed for your holidays? This is not a good question. So first of all, he has to say it is not a good question. You just need to give reasons why it is not a good question. So first one would be, and again, it's 2 because I've got 2 marks here. So the first one would be, it is a leading question. So essentially the question there is, how generous do you feel? So maybe it's not generous at all, but because you mentioned that, it is leading the person in a certain way. The second one we could have here is, it does not give options. So what I would prefer there is, with some answers, maybe 0 to, how generous do you feel? So it doesn't give us options, yes or no. It's very subjective. And another one we could have written there is, people may not want to answer. So it's quite a sensitive question. Some employees might think, I would get in trouble if I answer this in a certain way. So you may not necessarily get an accurate answer. The 30 employees in the office work in one of 2 teams, so team A 17, etc. One employee from team A is selected at random and one from B. Nolan is in team A, Jasser is in team B. Write down the probability that Nolan is selected. So Nolan is team A. He is one person out of 17, so that would be 1 out of 17. Jasser is in team B. He is only one person out of 13, so there's my answer. Who is more likely to be selected, Nolan or Jasser? Give a reason for your answer. Jasser, because 1 over 13 is greater than 1 over 17, so he's got a higher chance of being picked. You do need to obviously say whether it's Jasser or Nolan, and you do need to make reference to the numbers. Jasser on his own is not enough. So that is your reason, the fact that 1 over 13 is greater than 1 over 17. Number 3, so we've got a table. It shows the information about the sales of cars in the UK. And it is in September 2016 and September 2017. So 2016, we've got these 2 columns here. September 2017, these 2 columns here. And we've got a difference as well actually at the end, which we may need to use later. And there's 14 different car makers. Write down the market share for Audi in September 2017. So Audi is here, and we want to go over to 2017, which is here. This one is sales. We are looking for market share, which is 6.95%. So literally just reading it carefully off the table. Compare the Land Rover sales for 2017 to the Land Rover sales of 2016. So what we could say here, Land Rover sales, so 2016 equals 14,600. 2017, so 2017 decreases to 14,504. So the key thing there is you compare the 2 years, so 2017 is less than 2016, and you do include numbers. It could have been what the difference between the 2 of them was, but do reference some values. C. Which make of car had the smallest percentage increase in sales between 2016 and 2017? So change in sales, percentage sales, is this final row here. So it's done it for us, and we want which one made the smallest increase. So what we're looking for here is increases. So we want the positives. We're going to ignore the negatives. So we're looking at, there's a 1.7 here for Toyota, 3.6. So 1.7 seems to be the smallest. 7.7, 2.3. Nope, there's nothing smaller. 1.77, and that was Toyota. That made the smallest increase, and again it was only the increase we were interested in, so we excluded any negatives which represented a decrease. The next one, how many sales of these 14 top selling makes of car had greater sales in 2017 than 2016? So what we could do very easily is look again at change in percentage sales. So the negatives had a decrease from 16 to 17, the positives had an increase. So that would be 1, that would be 2, Toyota is 3, and there's another one here which is Kia. So there was 4 of them that had an increase. So literally just reading off the table, but reading it very carefully and referencing numbers where you need to. Right, number four, plot the average price for each of 14, 15 and 16. Right, so okay, we have got some of these in already. We've got 13, 10, 11, etc. So they've been done. We need to do these 3 up here. So 2014, and we're coming straight up from this line, we need to go 6.95. So 6.95, these are going up in, I believe it is 0.5s. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's where 6.9 is. So we'll put our X a little bit above that, but just below the 7. Next one, we got 2015 is 7.51. So that's 7.5. 7.51 would be just a tiny bit above it. But on this line here, 2015 line. And 7.95, there's 2016. So it is just below the 8.0. And that's what it looks like. On the grid, draw a trend line for Umer's data. So we need to make sure we've got a ruler for this bit and split those X's in half. So we have got a trend line. You can see it's increasing all along. So it looks roughly, we're starting at 17 and it's an upwards trend. It looks something like this. But the key thing is it's an increase. She's shown that increasing line. And they're all the X's are relatively close to that line, so we're following that similar trend. Describe the trend. In the average price of cinema tickets from 07 to 2016. So what we'd say here is we could say it's increasing. If you said it was upward, that's absolutely fine too. Rising because the average price is rising. So either of those would be absolutely fine. Umer uses statistical software to plot a trend line and find its gradient. The gradient is 0.3. We need to interpret this. So we just need to say, what does this relate to? So first of all, it's positive. So this shows an increase in its ticket prices, and that, yeah, in average price of a cinema ticket by 0.3, and it is in pounds. If we look back to our graph, it's in pounds, so it's 0.3 pounds, or you could write that as 30p, but do reference the 0.3. And the important thing is there that it is an increase every time because it's a positive gradient, just like our trend line is positive. Zara says that the scale used on the average price index could make the graph misleading. Explain whether or not she is correct. So on this one, Again, we need 2 points because it is 2 marks. So what we could say, if we look here, we could say that it should start from 0. So it starts from 5.00. So first of all, Zara is correct because, and 1, the vertical axis should start from 0. Okay, and that's all we really need on that one. So we've said that Zara is correct, and the main point there is it should start from 0, not from 5.0 as it is. The next one, last one, sorry. Bonnie wants to use a trend line for Umer's data in order to find an estimate of the average price of a cinema ticket in 2015 and 2025. Explain whether each of these is a sensible thing to do. Do not work out these estimates. So we need to explain whether it's right or not to do that and give a reason why. So first of all, 2012, sorry. If you look at our line, we've got 2012 is actually part of our graph. So it would roughly be about 6.5. So we would say 2012 would be, there's our word, so would be sensible because it is part of the range of data. So for example, our data was from 07 up to 2016, so we've got enough in there to be able to do some estimates for any ones that we're missing. So 2007 to 2016. And then 2025, so 2025 would, if you look at our table or our graph I should say, we don't have any information for 2025. As a matter of fact, we're about 9 years away from it. So a lot can happen from 2016 to 25 that would change our data. So I would say here 2025 would not be sensible because it is nowhere near the data we have. So there's a 9-year gap there. It's just far too big to try and predict. We could probably predict 2017 with our data, but anything beyond that really wouldn't be accurate. Right. A shop manager recorded a total number of each type of banknotes when the shop closed one Saturday. Here are the results. So in total there were 300 banknotes. One of the banknotes is selected at random. Find the probability that the value of the banknote is less than 20. So less than 20, we would have, we would have definitely the 84 because there's 5 of those. The 10s, that's less than 20 as well. And there are no other notes that are less than 20. We've got 20 there, but that would be equal to 20, so we're not including that. So probability as before, as a fraction, so there's 300 altogether. Notes under 20 would be 84 plus the 107, which is equal to 191 over 300. And looking at that, that can't be simplified. Leaving it as a fraction is absolutely fine. We haven't been told to do otherwise. So that is our answer, 191 over 300. The manager uses our data to predict the proportion of each type of banknote in use in the UK. Explain how the manager could improve her predictions So what you could do, we only need one here. Anytime you want to improve your predictions is increase the sample size. So if we could guess, this was for one day, if you remember. Yeah, one Saturday. So increase the sample size, i.e. do it over a week. Because you think about a Saturday is very different to a Monday or a Wednesday. Saturday is not a working day in terms of Monday to Friday. So it might be a case that people spend more on Saturdays, or maybe they spend less. So ideally you would do that over a week or even longer, but increase the sample size. Table below shows the true proportion of each type of banknote in use in the UK in 2017. So up here we had what it was in a shop, what they predicted. Here is what it actually was. And we are asked, for £10 banknotes, compare the true proportion in use in the UK in 2017 with the manager's predicted proportion. You must suggest a possible reason for any differences. So we look at £10. So here the prediction was 36%. What it actually was 23%. So we're going to note that first. So the prediction was 36%. The actual was 23%. And we need to suggest a reason why there is a difference there. Well, first of all, that's a difference of 13. No. This could be because we could say that people generally use smaller banknotes when shopping than was predicted. So you think about when you're shopping, if you do have banknotes, or cash I should say, it's generally that you wouldn't have £50 notes, £100 notes, etc.